we've looked at triangle congruencies. We've gone through the different ways. Now we just need to see that anytime you have a triangle proof, it's kind of a puzzle. And you use different pieces and how you get it to all fit together. They all pretty much start the same way. You're given some statements, you got two triangles. Whether they're sharing a side, sharing an angle, whatever the case may be, it starts there. Your goal is to get to side, 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 angle, side, angle, side, angle, 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 side, and HL. Now this isn't coming from any particular section. If you want to write this somewhere or take a picture of it when I'm done, that's fine. I just want to kind of show you where we're at so far. So our goal is to get from given this stuff to one of these. And once we do that, we can state how the two triangles are congruent. Again, that's our congruent statement. Triangle ABC congruent to triangle DEF. Now, back here where we start, we usually get 1 to 2 congruencies like side congruent to side, angle congruent to angle, whatever the case may be. And those are those automatic ones. They're given that we use those statements. They're typically even labeled in the diagram. It's what we do with the other information we're given and other stuff we have to get there. Typically, it's never enough over here. It's never enough to automatically jump. But we have to figure out what that middle ground is that allows us to get those next steps. What's a nice thing we have is those steps that we have kind of come from the same list we always can use. Fine, fine. You want to make fun with that box? We'll try again. You're terrible. All right, one of them that shows up a lot, reflexive property. Now, reflexive property typically shows up when we share a side. Two triangles, they share a side. We say that's congruent because that side is in both of them. Okay? We like that one. It makes it easy. It's almost seen so much, it's almost like a given. The one that's like reflexive property with angles is vertical angles. Vertical angles are when two sides intersect. That would be the angles on the opposite side of the vertex are congruent. What's nice is when we have our two triangles, we use those as vertical angles. So that is a common jump we can use. Next, we sometimes get a statement, and this statement usually comes from the givens. It'll be something about a midpoint, or a bisect, or an angle bisector. It'll usually tell you that in the givens. Here's a midpoint. Here's a bisector. This is an angle bisector. We get something statement there. That's not automatically a congruence, but it gets us to that next statement that gets us to the end. Now, a midpoint may look like a midpoint on a bottom side. A bisector would be if we had something like line AB bisects CD at point D, or at point E, and then it cuts into midpoint. Bisector, midpoint, when we're talking about segments, are kind of the same thing. And the other one we get is angle bisector, and that would be when the angle is cut into two congruent parts. So if you see a statement in the given saying something about a midpoint, something about a bisector, something about an angle bisector, you usually state this congruence, and it gets you to the end. It just gets you another congruence. Another one we sometimes get from the given is parallel lines. Now, what are two things that we look for when we get parallel lines? Alternate interior and corresponding. So if I get a statement over in the given that says parallel lines, I'm looking at those two, because that's probably a next step we're going to have. So we said alternate interior and corresponding. What's nice about narrowing down that list is it usually looks like one of two ways. Alternate interior can either be like the is it snapping to the grid? Try this again. Okay, something like that, where your alternate interiors are forming that Z that you have. You may also see alternate interior kind of looking like the vertical angles if they're the lines on the outside. You get the same thing. That one does not show up as much. You're more likely to see the rectangle or the parallelogram with the transversal diagonal. Then corresponding is probably just doesn't come up very much. Again, alternate interior is probably where you're going to see it the most. But corresponding is when you have two triangles next to each other. Let's say these are our parallel sides. Those would be your corresponding. Corresponding like the same location. Up until HL, that was most of them. There's rare exceptions we get that we could bring up, but really, most of your proofs, one of those. You get givens, one of those gets you to your congruence. The other one I would probably add is perpendicular. We saw that a little bit with HL. For perpendicular, when that's brought up, you're going to say that that gives you right angles by the definition of right angles. And then you probably want to say that right angles are congruent. So that even that comes in a process. If I see something about perpendicular, I say, oh, perpendicular means they have right angles. Right angles are congruent. Gives me another congruence. So this step here, this middle area, we need to pick the problem that, from the problem, we need to pick where we're going to use it to, again, get to our triangle congruence. Probably 95% of our proofs follow this. Given something, you got some sides, got some angles, you got something else, get you your third congruence, we get to here. As long as you learn how to recognize when these pieces show up and how we use them, and you can identify these different congruences when you actually use them, that's all these proofs are. They change just a little bit to get to that result.